Okay, so for question 11, we have a show that question. We're trying to show that this fraction can be expressed as this one here. Now, at the top, I've done a little bit of setup work. So I've written the numerator, and I've written a having all of the parts that it requires to have the same denominator. I've also done the same for b. B was missing the 1 minus 2x, and c was missing the x plus 2. Underneath here, we've also expanded out the bracket, so it's nicer for comparing. Okay, and here is our comparing. So I've got x squared, x, and the constant terms. This is the left-hand side, so there is a 4, a -1, and a 2. And on the right-hand side, the idea is that these values match. So x squared, for example, x squared can only appear from this value times this value here. And you get -2a lots of x squared. For the x values, that's why I actually sort of expanded this out. It makes this bit a bit easier. You can see that I've got, well, actually, hang on a second. Before I do that, what I've done next, actually, is I said, because 4 is equal to -2a, I said that a is actually just -2. And it works out slightly better if earlier rather than later we just put that value in. So as I was saying, for the x values, what we've got is we've got -1 on the left-hand side. And on the right-hand side, you can see that you would get multiplications like that one there. That gives you 6x. So that's why I've written a 6 here. For the b term, you get -2bx. So -2b is what we write. And for c, you've got cx, so 1c. Okay, so we can go through this process of comparing and make some equations, and then we write our equations out for these ones. So for the x terms, we have the equation of -1 equals 6 minus 2b plus 1c. And for the constant terms, without an x, we got 2 equals -4 plus 1b plus 2c. Now, if you just rearrange, so if you say, for example, -7 equals blah, 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 and 6 equals blah, 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 blah. Well, on my calculator, when I do that, I get a b value of 4, and I get a c value of 1. So a was -2. So those are my 3 values there, okay? Now, the idea is that when we do that, it makes integrating a little bit easier. So instead of integrating this here, what we would do first is we would substitute in our values. So I believe it was -2, and then 4 goes with the x plus 2, and 1 goes with this final term. Okay, so if we integrate that, we would get 2x. When you've got something like this, natural log is typically what you're looking for. When you've got something in the denominator with x and there's no power on the whole bracket. Okay, so best guess, let's leave the 4 alone. Let's try natural log of x plus 2. Does it work? Yes, because it goes to this one here, and then the 4 just sort of sits out the front and it goes back. Okay. How about the next one? So a bit more difficult, this one, because of this part here. So what we might do is we might have a guess that this is the right way to go. And then we might just compare, I'll put the plus c, we might just compare to what happens. So if I differentiate this, I would get 1 over 1 minus 2x, which is good. But because of the minus 2x, I would also get a times -2. Now, I don't want that. I want to just get the value 1. It should take me back. So to compensate for that, I can put a minus 1/2 there. Because what that will do is it will now multiply that so that I just get what I just get what I had before. So that's the idea. So I'm doing a bit of compensating. You could do the substitution method with this, but this is much, much quicker. So that's going to be, in fact, let's just change that to a minus. There we go. So -1/2 and so on and so on. Now on this question, it doesn't ask for anything in particular, so I would actually just leave that one there. You could, in theory, you could do some more log rules. So you could do something like natural log of x plus 2 to the 4 minus natural log of root 1 minus 2x and stuff like this, and use log rules, but they're not asking for that in this question. So we're actually just going to stop on this line here. Okay, so we were doing some partial fractions rather quickly by using a table there for comparing coefficients. You can do that when you are given the format or you are confident of how to express the format. And finally, we had our integration at the end there.